Welcome to our foundational course on cybersecurity. In this video, we will explore the core components that make up a Security Operations Center, or SOC. Understanding these elements is crucial for protecting any organization's digital assets. The SOC is the centralized unit tasked with overseeing and managing an organization's overall security stance. This unit usually comprises security experts tasked with detecting, addressing, and reducing security threats. Let's get started on demonstrating a clear understanding of what a modern society entails. The Security Operations Center, or SOC, is essentially the command center for cybersecurity. It is a centralized unit composed of experts who manage and improve an organization's security stance. Their main purpose is to continually detect, analyze, and respond to any security events or threats. To be successful, the SOC operates through three fundamental and highly connected pillars: skilled people, well-defined processes, and effective technology. These three areas work together to ensure constant 24/7 monitoring of the network and systems. By focusing on incident detection and response, the SOC aims to safeguard the organization's infrastructure and maintain peace of mind for all stakeholders. We will explore each of these core pillars in the next slides, starting with the human element that brings the whole operation to life. Remember, a successful society is constantly adapting and improving its defenses based on real-world incidents. This constant vigil helps protect sensitive data and overall operational continuity against evolving threats and attacks. The people pillar is arguably the most vital component, as it converts technology and processes into actionable defense. The structure of this team is carefully designed to handle diverse threats. The SOC manager is responsible for overall team management, creating policies, and aligning security with business goals. The team hierarchy often starts with Tier 1 analysts, or triage specialists, who are the first to look at incoming alerts. They must quickly determine if an alert is legitimate or a false positive to avoid analyst burnout, a critical challenge in legacy SOCs. If a threat is confirmed, the incident responders step in. Their role is to limit the damage, eradicate the threat, and coordinate recovery efforts. Finally, the most experienced staff are the threat hunters, typically Tier 3 analysts. They proactively search the network for hidden threats that automatic tools might have missed, using advanced analysis techniques. This specialization promotes efficiency and quick decision-making within the society. This chart illustrates the key roles within the society team and how they interact, ensuring a clear chain of communication. The SOC manager oversees all operations at the top of the structure. The Tier 1 analyst, or triage specialist, continuously monitors the incoming alerts. If an alert is confirmed as a legitimate threat, the Tier 1 analyst escalates it to the incident responder. The incident responder's immediate priority is to contain and mitigate the security incident. Meanwhile, the threat hunter, usually a Tier 3 analyst, works proactively, hunting for undetected threats within the environment. Both the incident responder and the threat hunter contribute critical findings and insights back to the society manager. These insights are essential for the continuous improvement loop, helping the manager refine policies and defenses. The division of labor, from triage to deep investigation and strategic management, is crucial for promoting specialization and flexibility, allowing the SOC to respond quickly and effectively to various security incidents. Now we move to the technology pillar, starting with the foundation, Security Information and Event Management, or SIEM. A SIEM solution is indispensable for a modern SOC, essentially serving as its central nervous system. The first key function is data aggregation and normalization. Imagine collecting data from hundreds of different types of devices, all speaking different security languages. SIEM gathers all this information and translates it into a single unified language. This standardized data then enables event correlation. This is where the SIEM truly shines, connecting separate low-level events, like multiple failed logins from a specific IP address, to uncover signs of a larger, coordinated attack that a single alert would miss. When threats, anomalies, or known indicators of compromise are identified, the SIEM generates prioritized alerts. These alerts are the primary signal that the society analysts act upon, providing the immediate notification necessary for threat detection and ensuring monitoring accuracy. This graph illustrates the workflow of the Security Information and Event Management, or SIEM, system. The process begins with diverse data sources, such as logs from firewalls, servers, endpoints, and cloud platforms. All this security data flows into the centralized SIEM system. The first step inside the SIEM is data normalization, where the raw, varied log data is converted into a standardized, common format. This standardized data is essential for the next critical step, event correlation and analysis. In this stage, the SIEM applies predefined rules and algorithms to link related events across different sources and identify suspicious patterns indicative of a threat. If a potential security issue is identified, the system generates a prioritized alert, which is the immediate signal for the society team to start their investigation. By consolidating and analyzing data from across the enterprise infrastructure, the SIM provides a comprehensive view crucial for effective threat detection and response in the SOC. Building upon the SIEM's detection capabilities, the next essential technology is security orchestration, automation, and response, known as SOAR. While the SIEM flags potential issues, the SOAR platform is the central hub designed to automate nearly all incident response workflows. Think of the relationship like this. CM tells you what's wrong, and SOAR automatically fixes it or prepares it for human intervention. A core part of SOAR is the use of automated playbooks. A playbook is a set of predefined actions or steps that are triggered automatically by a security alert, ensuring consistent execution and machine speed response. By handling mundane, repetitive tasks like enriching an alert with threat intelligence data or isolating an infected host, SOAR frees up human society analysts to focus only on complex, high-impact incidents. This automation is critical for reducing the mean time to respond, or MTTR, leading to better security outcomes and significantly reducing staff burnout. This flowchart illustrates how the SOAR platform executes an automated response triggered by an alert from the CM system. The process begins when a SIEM alert is generated, signaling that a threat has been detected. This alert immediately triggers a predefined workflow, known as a playbook, within the SOAR platform. The playbook executes necessary tasks, such as Step 1, data enrichment, which automatically gathers additional context about the threat, perhaps pulling in data from threat intelligence feeds. Concurrently, it executes Step 2, automated action, such as instantly isolating the compromised endpoint from the network, containing the threat at machine speed. After initial enrichment, if required, the data proceeds to analyst review for human oversight and complex decision-making. The goal of this entire automated process is rapid threat containment. This efficient coordination between CM and SOAR drastically speeds up incident response and minimizes potential damage. Next, let's examine Extended Detection and Response, or XDR, and its foundation, EDR. XDR is a crucial evolution for the modern SOC, providing comprehensive visibility that goes beyond traditional boundaries. Instead of separate tools for checking endpoints, networks, and cloud infrastructure, XDR pulls all this disparate telemetry data together into one cohesive system. This integration is vital because it allows the SOC to see the full attack chain, linking initial access all the way through to lateral movement and final objectives. EDR, or Endpoint Detection and Response, is a core part of this, focusing specifically on deep visibility into device activity, enabling security analysts to perform detailed forensic analysis after an incident. XDR utilizes machine learning and behavioral analysis to detect anomalies, grouping related alerts to reveal the true root cause of complex attacks, which greatly speeds up triage and investigation for analysts of all skill levels. This diagram illustrates how Extended Detection and Response, or XDR, unifies visibility across the security environment. XDR collects and integrates data from multiple data sources that were historically siloed. These sources include endpoints, network traffic, cloud workloads, and even identity and applications. All this telemetry is fed into the central XDR platform. The power of XDR lies in its ability to correlate this diverse data using analytics and machine learning. By stitching together these pieces, XDR provides a unified incident view that shows the entire attack chain, which is essential for rapid threat resolution. Furthermore, XDR executes automated responses, such as quarantining an endpoint or blocking an IP address based on the identified threat. XDR drastically enhances the SOC's capability to detect and respond to complex threats quickly and accurately by bringing all necessary telemetry into a single, cohesive system. Threat intelligence, or TI, is a crucial process component for any modern society. It involves collecting and analyzing evidence-based knowledge about existing or emerging threats that could harm organizational assets. TI moves the SOC from a purely reactive stance to a proactive defense strategy by helping security teams anticipate an attacker's next steps. There are two key types of data within threat intelligence. First, indicators of compromise, or IOCs, are like digital footprints left by attackers, such as malicious IP addresses or suspicious file hashes. Second, tactics, techniques, and procedures, or TTPs, describe the specific methods threat actors use to achieve their goals. The SOC operationalizes this intelligence by feeding IOCs and TTPs directly into security tools like CM and XDR. This integration enables automated systems to automatically scan for known malicious indicators, greatly accelerating threat detection and allowing the organization to proactively block attacks before they cause major damage. This visual represents the cyclic process of the threat intelligence lifecycle, a key operation within the society. It begins with direction or discovery, where the SOC identifies its specific intelligence needs. This phase determines what kind of data the team needs to collect to prepare its defenses. Next is collection, where raw data is gathered from various internal and external sources, such as public threat intelligence feeds or internal incident reports. the data then moves to analysis, where analysts distill the raw information into actionable knowledge, specifically identifying key indicators of compromise, or IOCs, and understanding the attacker's tactics, techniques, and procedures, or TTPs. Finally, the action phase ensures this intelligence is integrated directly into SOC tools, such as SIEM and XDR, enabling real-time detection and automated responses. This information then feeds back into the direction stage, creating a continuous improvement loop that keeps the society prepared for evolving threats. When a threat is detected, the SOC executes its incident response, or IR, lifecycle. This is a crucial, structured methodology designed to minimize damage and ensure a swift recovery from any security event. The first stage is preparation, which occurs long before an attack. This involves creating detailed policies, assembling the response team, and running regular training exercises. When an incident occurs, the identification phase uses tools like SIEM and XDR to confirm the abnormal activity and assess the scope of the attack. Once identified, the team moves into active response, starting with containment, where affected systems are immediately isolated to stop the threat from spreading. This is quickly followed by eradication, removing all malicious elements, and recovery, safely restoring systems to normal operation. The final and most critical step for the SOC is to apply the lessons learned to refine existing plans and controls, ensuring continuous improvement of the organization's defense posture. This flowchart details the incident response lifecycle based on widely accepted cybersecurity frameworks. The process is cyclical, beginning with Phase 1, preparation. This foundational phase ensures that policies, tools, and response teams are ready before any incident occurs. An actual security incident then moves the process to Phase 2, identification, where the SOC detects and confirms the scope of the malicious activity using monitoring tools. Next comes Phase 3, containment, a critical step where the spread of the threat is limited by isolating the affected systems. Following containment is Phase 4, eradication and recovery, where malicious elements are removed and normal operations are restored. The entire cycle concludes with Phase 5, lessons learned and improvement, ensuring that findings inform better security controls and refine the incident response plan itself. This final step loops back to preparation, closing the loop and strengthening the organization's resilience against future cyber attacks. To conclude, the traditional society built around older CM technology is struggling to keep up with today's immense volume and complexity of threats. Analysts suffer from alert fatigue because too many alerts are low-value noise, and data is often stuck in separate silos like endpoint or cloud systems. The future solution is the AI-driven, autonomous SOC, which radically shifts the model by leveraging automation for the bulk of the repetitive work. Extended Security Intelligence and Automation Management, or XSIAM, embodies this shift. XSIAM is designed to be the new center of SOC activity, replacing legacy CM systems by converging capabilities like XDR, SOAR, and threat intelligence into one single platform. By embedding AI and machine learning, XSIAM automatically stitches together raw data, reducing low-confidence alerts and focusing human analysts only on urgent, high-impact incidents. This revolutionary approach simplifies security operations and accelerates incident response times dramatically, ensuring a more scalable and resilient defense. This visual illustrates the shift from siloed tools to a modern, consolidated SOC model centered around XSIAM. Historically, technologies like the legacy CM, XDR platform, SOAR and automation systems, and separate threat intelligence feeds operated somewhat independently. The concept of XSIAM, or Extended Security Intelligence and Automation Management, converges these capabilities into a single, unified platform. The core power of this platform lies in its AI-driven analytics and automation capabilities. This intelligence allows XSIAM to stitch together data intelligently, perform real-time correlation, and prioritize high-fidelity incidents, fundamentally changing how security operations function. The ultimate measurable benefit of this convergence and automation is a significant reduction in mean time to detect and mean time to respond, making the entire society operation faster, more accurate, and far more scalable than older architectures. This unified approach eliminates the operational complexity of managing disparate tools, delivering a streamlined security outcome.